Hey everyone, welcome back to another video. Today, go over Leetcode problem 2685, count the number of complete components. So in this problem, we're given an integer n and an undirected graph with n vertices, numbered 0 to n minus 1. Then we're also given an array of edges here, and that just denotes that there's an undirected edge connecting the two nodes together, and we want to return the number of completed connected components of the graph. They tell us here that a connected component is a subgraph of a graph which there exists a path between any two vertices and no vertex of the subgraph share an edge with a vertex outside of the subgraph. So basically all that means is there exists a subgraph where all nodes in that subgraph connect to one another. So I think this is the best example they have here, where 0 connects to 1 and 2, 1 connects to 0 and 2, 2 connects to 1 and 0. And you can kind of see that this is also a complete component here because it's one node and it connects to nothing, but that's considered a complete component. And then here, these two nodes here, see they connect to each other. Even though it's just one edge connecting them, that still counts. So kind of work out the rule here. If there's one node, it should be 0 vertices. There's 2 nodes, 1 vertice. If there's 3 nodes, it should be 3 vertices. And if there's 4, we can kind of draw that out here, what 4 would look like. 1, 2, 3, 4. So these will connect to each other. And these can also connect this way. You count 1, 2, 3, 4, 5, 6. So 4 would connect to the 6 vertices. So, I mean, kind of knowing that each vertices or each node needs to connect to n minus 1 other nodes in that complete component, you can kind of see that we're looking for that many kind of edges in each little subcomponent we find. You could also say that's divided by 2, but since this is an undirected graph, this actually counts as 2 edges here because it accounts from 1 to 2 and also 2 back to 1. Same thing for all these nodes here. So, anytime we're working with a graph here, we kind of know we're going to be doing DFS or BFS. So, I think a good idea here would be to just do DFS over each node and just go over, mark nodes as visited as we go past them so we don't do DFS over these nodes again, and then count for each component how many edges and vertices there are. And then if the number of edges is equal to the amount of nodes times nodes minus 1 in that little subcomponent, we can count that as a complete component. So kind of just go over an example here. See, we have 0. Start the DFS there. And we'll just count. And we can count here. There's 3 nodes here, and then there's 1, 2, 3. And it's kind of 3 times 2 again because they connect to each other both ways. So that's 6 edges there. And then if you plug it in, n minus 1, 3 minus 1 is 2 times 3 is 6. That's a complete one. Quickly just do these 2 here. See, there's 2 nodes and 1 edge that connects them. So 2 times 2 minus 1 is 2. That's also a complete component. And then 5, that'd be 1 times 1 minus 1, which is 0. 0 edges there. So that's how we get the output of 3. So now we can go over to Leetcode and kind of put this into code. All right, so we're back in Leetcode here. First thing I like to do anytime I have a graph is just turn that adjacency list into a more approachable graph object here. So we'll take that and make this map over here. So that kind of makes this connection where you'll have this hash map that's like this. 0 connects to 1 and 2. 1 connects to 0 and 2. And 2 connects to 0 and 1, and so on for the rest of the nodes. Then, like I said before, we're going to want to run DFS over every node. So check, we have a visit array to mark these as visited. So make that after, but you see if the node isn't visited, we can run DFS on that node, and the DFS will be counting the nodes and edges. And then do that, and then we could say if if nodes times nodes minus 1 is equal to edges, and say that that's a complete component here. So let's make that visited array, where it'll just be an array false, where each index represents if that node has been visited or not. And set answer here. Just don't forget, sure we don't return it. So now we can actually do the DFS here. So all I want to make sure we do for the DFS is we don't double count nodes. So do visited node true. That means we visited already. Just return 0 nodes, 0 edges. Now we're going to want to set that over visit now equal to true, saying that we visited it. And then we can start exploring the rest of the component. So say nodes equal to 1, that's node we visited now, and edges equal to the length of its edges. So do that by checking the graph and getting all its how many edges it has. And now we can kind of explore all of its neighbors. So for neighbors in graph node, we can say it's sub edges or sub nodes, sub edges, DFS of neighbor. And then we can just add those for count. Edges equals sub edges. And then we can just return node edges here. So that should be it. Let's run it to make sure. Oh, let's see. It should just be neighbor here. Let's see. Maybe I forgot to return something. Answer. Okay, I was looking for my bug here, but it's just because I returned 0 here. Then I also just made a typo here. Plus equal, so logic should be correct. Let's submit that, and there we go. So thank you guys for watching. If you guys have any other suggestions for another video to do a specific problem, let me know and I can explain it and go over it. But that's all for me today. Thank you guys.